And finally we get final pavement design. Understand an important concept. When the wheel load comes on the pavement, it gets distributed in the layers below. The stress is maximum on the top layer, and the stress decreases with depth. Pavement layers are designed based on this principle. Bituminous layer, DBMMMGSB, and subgrade. Now let us come to practical engineering notes. Incorrect design procedure can result in unsafe pavement. Numerical understanding increases your confidence. IRC provisions ensure standardization we do. And using the correct formula gives accurate results. Now a quick formula recap. MSA calculation, design relationships, and structural number concepts will be covered in this part. In typical calculation you are given parameters like traffic, CBR, reliability, design life. And you have to find out the total pavement thickness. Key clauses of IRC 37 will also be covered in this part. From clause 4 to clause 8, which define the design inputs, procedure, and construction requirements. Now remember one line. Part 4 means design plus numerical plus IRC plus formula. And what is the final goal? Should be clear. So the pavement will be safe. So let's get started. Step-by-step journey of IRC 37 flexible pavement design. Hello engineers. Welcome to Civil Engineering Infrastructure. Today we are starting part 4 of IRC 37 flexible pavement design. This part is very important because from here the real understanding of the actual pavement design starts. This section covers slides 31 to 35. Each slide focuses on a specific concept. We'll understand the entire design process step by step. The structure of this part. In slide 31 we will learn the complete design procedure. That is how pavement design is done step by step according to IRC 37. We will do a numerical example in slide 32. Here you will see the actual calculation. You will understand the complete practical approach from traffic to thickness. Slide 33 we will cover important IRC clauses, which are very important for exams, interviews and site work. Slide 34 we will see the complete design flowchart. With this the entire process will be cleared in a sequence. Revise the formula in slide 35. That means all important formulas at one place, due to which your revision will be strong. The learning outcome of this part. After this section you will understand the design procedure, solve numerical problems, confidently use IRC clauses, develop flowchart-based thinking, and revise formulas easily. Understand this design flow carefully. First comes traffic data. This is where the design begins. After this comes CBR selection. This indicates subgrade strength. And this controls the pavement thickness. Then comes MSA calculation. That means total traffic loading during design life. This is the most critical parameter for design. After this we do thickness selection based on IRC design charts. Then comes verification. It checks whether the design is safe or not. SLID 31. IRC 37 pavement design procedure step by step. So friends, till now we have understood flexible pavement structure, drainage, failures, construction quality, and overlay concepts in detail. But now we have reached the most important topic. which decides the actual pavement thickness. And that is IRC SATI's pavement design procedure. That is, how is highway pavement scientifically designed? This entire methodology is explained step by step in this slide. So let us understand the entire slide in detail. एक introduction to IRC SATI's design procedure. IRC SATI's provides guidelines for flexible pavement design. It bases pavement design mainly on these parameters: traffic loading, subgrade strength, material properties, and pavement thickness is designed like this, so that it can safely carry cumulative traffic throughout its design life. See the engineering note below. Flexible pavement design balances traffic loading and pavement strength. This is the core principle of pavement design engineering. Now let us look at the second topic. Two basic design inputs. What inputs are required for flexible pavement design? Design traffic, subgrade CBR value, design life, vehicle damage factor, lane distribution factor, traffic growth rate, reliability and drainage condition. And all these inputs control the pavement thickness calculation. Now let us look at the third topic. 3-step 8. Traffic survey. The first step is traffic survey. Is conducted to determine commercial vehicle movement. Now look at the data collected. Daily traffic volume, axle load data, traffic growth rate, vehicle classification. Now see engineering warning below. Inaccurate traffic survey causes incorrect pavement thickness. If the traffic data is wrong, so the entire pavement design may become unsafe. Now let us look at the fourth topic. 4-step 2. Calculation of design traffic. Design traffic is expressed in million standard axles IMSA. The traffic formula is given here. N 365 times A times left frac 1 plus R N 1 R right times F times D, where N design traffic in MSA, A initial commercial vehicles per day, R annual growth rate, N design life in years, F vehicle damage factor, D lane distribution factor. And this same formula is used to calculate cumulative traffic loading. Now let us look at the fifth topic. 5-step 3. Subgrade investigation. Now the subgrade soil strength is evaluated. For this, laboratory CBR test, field CBR test, soil classification, moisture content evaluation is done. See the engineering note below. Higher CBR reduces pavement thickness requirement. Now also see typical CBR ranges on the right side. Weak soil 2% to 5%. Medium soil 5% to 10%. Strong soil above 10%. And this is why thicker pavement is required in low CBR soil. Now let us look at the sixth topic. 6-step 4. Selection of design CBR. Here the design CBR value is selected. Now look at the engineering concept. Low CBR thick pavement, high CBR thin pavement. And this graph is also showing this. Now let us look at the seventh topic. 7-step 5. Selection of pavement composition. Now the pavement layer composition is decided. Typical flexible pavement layers. 1. Bituminous concrete BC. 2 dense bituminous macadam DBM, 3 wet mix macadam WMM, 4 granular sub-base GSB, 5 subgrade, and each layer has a specific structural function. Now let us look at the 8th topic. 8 step 6. Determination of pavement thickness. Now pavement thickness is determined using IRC, Santie's design charts. On which factors does thickness depend? Traffic loading, subgrade strength, drainage condition, material quality, design life. Now look at the graph. Thickness increases as traffic increases. As CBR increases, thickness decreases. And this is the flexible pavement design logic. Now let us look at the 9th topic. 9 step 7. Drainage consideration. Drainage design is also an important part of pavement design. Proper side drainage, cross-slope provision, shoulder drainage, prevention of water infiltration. Now see engineering warning below. Poor drainage drastically reduces pavement life, and water infiltration accelerates pavement distress. Now let us look at the 10th topic. STEP art, fatigue and rutting check. Two major criteria are checked in flexible pavement design. Fatigue check, prevent cracking. Rutting check, prevent deformation. See the engineering note below. Both fatigue and rutting criteria must satisfy IRC limits. And IRC Santie's design is based entirely on fatigue and rutting performance. Now let us look at the 11th topic. 1 step No. Material selection. Material selection directly affects pavement durability. Now look at the requirements. Proper aggregate quality, suitable bitumen grade, layer stiffness consideration, durability requirements, temperature suitability, and material selection is done according to the climatic condition. Now let us look at the 12th topic. 1-2 step thus. Construction quality control. Good construction quality ensures design performance. Now look at the quality control requirements. Density testing, layer thickness checking, compaction control, material testing, surface smoothness checking, and improper construction design can reduce life. Now let us look at the 13th topic. 1-3 pavement design flow logic. This entire pavement design sequence is shown. Traffic data, CBR testing, MSA calculation, thickness design, drainage check, fatigue and rutting check, final pavement composition. And this is the complete IRC Santie's pavement design workflow. Now let us look at the 14th topic. 1-4 practical site observation. Incorrect CBR value leads to unsafe design. Poor drainage weakens pavement layers. Overloaded vehicles increase pavement distress. Low compaction reduces pavement life. SLID 32. Numerical example of pavement design. So friends, till now we have understood IRC Santie's pavement design procedure in full detail. But now the most important practical part begins. And that is numerical pavement design example. Because in actual highway projects, pavement thickness calculation is determined only through numerical analysis. And this entire step-by-step calculation is explained in detail in this slide. So let us understand the entire slide in a practical way. 1 Keycap Introduction to Numerical Design Example. Numerical design examples help us understand the practical application of IRC 37 pavement design methodology. Here pavement thickness is calculated on the basis of traffic loading and subgrade strength. See the engineering note below. Numerical analysis converts field data into pavement thickness. That is, field investigation data is converted into design thickness. Now let us look at the second topic. Though given design data. Here is the required field data for pavement design. Initial traffic A. 4500 CVPD. Annual traffic growth rate R. 7.5%. Design life N. 15 years. Vehicle damage factor F. 4.5. Lane distribution factor D. 0.75. Subgrade CBR 5%. Road type National Highway. And these actual inputs will be used for pavement thickness design. Now let us look at the third topic. 3 Step 1. Design traffic calculation. IRC 37 traffic formula is used here. N 365 times A times left frac 1 plus R N 1 R right times F times D. Where N design traffic. A initial commercial vehicles per day. R annual growth rate. N design life. F vehicle damage factor. D lane distribution factor. And this formula calculates cumulative design traffic. Now let us look at the fourth topic. 4 Step 2. Traffic growth calculation. Now the growth factor is calculated. Frac 1 plus 0.075 15 1 0.075 approx 25.13. Here is the approximate growth factor. 25.13. It is coming. And this represents future traffic growth. Now let us look at the fifth topic. 5 Step 3. Final design traffic. Now all the values are substituted in the formula. N 365 times 4500 times 25.13 times 4.5 times 0.75. Final result. N approx 139 text MSA. See the engineering note below. Higher MSA requires thicker pavement layers. That means as the traffic loading increases, the pavement thickness also increases. Now let us look at the sixth topic. 6 Step 4. Selection of pavement thickness. Now IRC 37 design chart is used. Here, traffic 139 MSAs. CBR 5%. Pavement thickness is selected according to these values. Now look at the design chart on the right side. As CBR increases, the thickness decreases. And the thickness is increasing with higher traffic. Now look at the selected pavement composition. BC 40 mm. DBM 160 mm. WMM 250 mm. GSB 200 mm. Subgrade compacted soil. Now let us calculate the total pavement thickness. 40 plus 160 plus 250 plus 200 650 text mm. And this is the final pavement thickness. Now let us look at the seventh topic. 7 final pavement layer composition. Pavement cross section is shown here. Top layer BC 40 mm. Binder layer DBM 160 mm. Base layer WMM 250 mm. Sub base layer GSB 200 mm. Foundation subgrade, and this is the complete flexible pavement structure. Now let us look at the eighth topic. Art wheel load stress distribution. Now let us understand the wheel load distribution mechanism. Wheel load stresses gradually reduce with depth. Now see the engineering concept below. Surface layer, high stress. Lower layer, reduced stress. The stress distribution becomes wider as we go down. Now let us look at the ninth topic. No importance of CBR in design. Here, CBR 5% has been given. What does it mean? Medium strength subgrade. Moderate pavement thickness required. Adequate compaction essential. Now look at the comparison box. Low CBR 2% to 5%. Thick pavement. Medium CBR 5% to 10%. Moderate thickness. High CBR above 10%. Thin pavement. And this is the subgrade strength concept. Now let us look at the 10th topic. FATIGUE and rutting criteria. Flexible pavement design is based on two major failure criteria. Fatigue criteria. Controls cracking from repeated loading. Rutting criteria. Wheel path deformation controls. Now see engineering warning below. Both criteria must satisfy IRC 37 limits. If both the criteria are not satisfied, then the pavement design will be considered unsafe. Now let us look at the 11th topic. 1. Drainage consideration. Drainage design is also critical to pavement performance. Side drains provided. Cross slope maintained. Shoulder drainage ensured. Water infiltration minimized. And poor drainage reduces pavement life. Now let us look at the 12th topic. 1. Construction quality requirements. Proper construction quality maintains design performance. Proper layer compaction. Thickness control. Density achievement. Temperature monitoring. Material testing. Surface smoothness checking. And quality control failure increases pavement distress. Now let us look at the 13th topic. 1. Practical site observation. Incorrect traffic data causes unsafe design. Weak subgrade increases pavement thickness. Poor compaction reduces pavement performance. Water stagnation damages pavement layers. And these are the practical observations of highway engineering. Now let's look at the 14th topic. 1. Important engineering concepts. Flexible pavement acts as layered structure. Bituminous layer resists tensile stress. Granular layer distributes wheel load. Subgrade strength controls overall thickness. And this is the structural behavior of flexible pavement. Now let us look at the 15th topic. 1. Interview question box. Why is MSA important in pavement design? Answer. MSA represents cumulative traffic loading during design life. Q. What happens if CBR value decreases? Answer. Pavement thickness requirement increases. Let's look at one short revision at the bottom. Traffic load. MSA. Subgrade strength. CBR. Higher traffic. Higher thickness. Weak soil. Thick pavement. Proper drainage. Better pavement life. IRC 37. Flexible pavement design guideline. And this is a complete numerical pavement design example. And now on to the next slide. We will understand the important IRC 37 clauses and key design recommendations, where pavement design limits, layer requirements, and specification-based concepts will be understood in detail. SLID 33. Important IRC 37 clauses and provisions. So friends, till now we have understood IRC 37 pavement design procedure, numerical example, and flexible pavement behavior in detail. But now the most important theoretical and practical topic begins. And that is important IRC 37 clauses and provisions. Because highway pavement design is completely based on IRC 37 guidelines. If IRC provisions are not followed properly, so the pavement may be unsafe, uneconomical, and prone to premature failure. And these entire technical requirements have been explained in detail in this slide. So let us understand the entire slide step by step. एक introduction to IRC 37. IRC 37 provides guidelines for flexible pavement design. This code designs pavement thickness based on traffic loading, subgrade strength, and material properties. And its main purpose is to provide safe, durable, and economical pavement design. See the engineering note below. IRC 37 is the primary guideline for flexible pavement design in India. And practically most of the highway pavement designs in India are done as per IRC 37. Now let us look at the second topic. The main objectives of IRC 37. The major objectives of IRC 37. Standardization of pavement design. Improvement in pavement durability. Safe traffic carrying capacity. Reduction in premature failures. Scientific pavement thickness design. Better maintenance planning. And this is the core objective of pavement engineering. Now let us look at the third topic. 3 important design inputs as per IRC 37. Important input parameters are required for IRC 37 design. Design traffic in MSA. Subgrade CBR value. Vehicle damage factor. Design life. Lane distribution factor. Drainage condition. Material properties. अब नीचे engineering warning देखिए. Inaccurate input data results in unsafe pavement design. And this is the most critical requirement of field design. Now let us look at the fourth topic. Chart traffic design provision. IRC 37 design expresses traffic in million standard axles IMSA. And for this IRC traffic formula is used. N 365 times A times left frac 1 plus R N 1 R right times F times D. अब important traffic concepts देखिए. Cumulative traffic loading. Traffic growth consideration. Lane distribution effect. Axle load damage concept. And these parameters control the pavement thickness. Now let us look at the fifth topic. 5 subgrade design provision. As per IRC 37, pavement design is based on subgrade CBR value. Now look at the most important concept here. Low CBR. Higher pavement thickness. High CBR. Lower pavement thickness. Because weak soil cannot provide much structural support. See the engineering note below. Subgrade is the foundation of pavement structure. And that is why subgrade quality is very critical. Now let us look at the sixth topic. 6. Pavement composition provision. Typical flexible pavement layers are shown here. 1. Bituminous concrete. BC. 2. Dense bituminous macadam. DBM. 3. Wet mix macadam. WMM. 4. Granular sub-base. GSB. 5. Prepared subgrade. And this is a complete layered pavement system. Now let us look at the seventh topic. 7. Fatigue criteria provision. IRC 37 limits the bottom tensile strain of the bituminous layer. Its main purpose: prevention of fatigue cracking, improvement in pavement life, structural safety. Now see the engineering concept below. Lower tensile strain, longer pavement life. And this is the fatigue failure control concept. Now let us look at the eighth topic. 8. Rutting criteria provision. IRC 37 controls the vertical compressive strain on the subgrade. Its purpose: prevention of rutting, reduction in permanent deformation, improvement in riding quality. Now see engineering warning below. Excessive compressive strain causes rutting failure. And this is the main reason for wheel path deformation. Now let us look at the ninth topic. No drainage provisions. Proper drainage is very critical to pavement performance. Adequate side drainage, cross slope requirement, shoulder drainage, water infiltration prevention, rapid removal of rainwater. See the engineering note below. Poor drainage drastically weakens pavement layers. And this is the major reason for field failures. Now let us look at the 10th topic. MATRIAL quality provisions. Specifies the quality requirements of both aggregate and bitumen. Strength, durability, proper gradation, abrasion resistance, bitumen requirements, proper viscosity, temperature suitability, adhesion characteristics, and improper material quality pavement increases distress. Now let us look at the 11th topic. 1. Design life provision. IRC design life varies according to different road categories. National Highway 15 to 20 years. Urban roads 10 to 15 years. Expressways 20 to 30 years. Now see the engineering concept below. Higher design life, higher pavement thickness, because future traffic loading also increases. Now let us look at the 12th topic. 1. Construction quality provisions. IRC 37 places great emphasis on proper construction quality. Layer-wise compaction, thickness control, density testing, surface smoothness, temperature control, material testing compliance, and poor construction quality reduces pavement life. Now let us look at the 13th topic. 1. Overlay design provision. Overlay design is used for strengthening existing pavement. This requires existing pavement evaluation, deflection-based overlay design, crack control measures, structural strengthening requirement, and overlay thickness depends on the pavement condition. Now let us look at the 14th topic. 1. Pavement performance concepts. Flexible pavement layered load distribution system की तरह behave करता है. Layered load distribution, fatigue resistance, rutting resistance, moisture susceptibility control, Structural reliability. Now look at the stress distribution diagram. Stress gradually decreases with depth. And this is flexible pavement structural behavior. Now let us look at the 15th topic. 1.5 Practical site observation. Incorrect traffic data causes unsafe design. Weak subgrade increases pavement thickness. Poor compaction reduces pavement performance. Water stagnation damages pavement layers. And these are the common highway field observations. Now let's look at the 16th topic. 1.6 Important IRC engineering concepts. Pavement behaves as multilayer system. Stress decreases with depth. Stronger subgrade reduces pavement thickness. Proper drainage improves pavement durability. और यही IRC 37 pavement engineering fundamentals हैं. Now let us look at the 17th topic. 1.7 Interview question box. Q. What is the purpose of IRC 37? Answer. To provide guidelines for design of flexible pavements. Q. Why is CBR important in IRC 37? Answer. CBR represents subgrade strength and controls pavement thickness. Let's look at one short revision at the bottom. Traffic load. MSA. Subgrade strength. CBR. Higher traffic. Higher thickness. Weak soil. Thick pavement. Fatigue check. Crack control. Rutting check. Deformation control. Proper drainage. Longer pavement life. IRC 37. Indian Roads Congress Guideline. And these are the complete IRC 37 clauses and pavement design provisions. And now on to the next slide. We will understand flexible pavement design flowchart and complete revision concept, where you will understand the entire pavement design process in a simplified engineering flow. SLID 34. Flexible pavement design flowchart. So friends, till now we have understood IRC 37 clauses, pavement thickness design, fatigue criteria, rutting criteria, and numerical example in detail. But now comes the most important practical topic. And that is flexible pavement design flowchart. How the entire IRC 37 pavement design process is executed step by step. Because in actual highway projects, pavement design is always done in a systematic sequence. If the design flow is not correct, so the entire pavement design may become unsafe. And this complete design methodology is explained in this slide. So let us understand the entire slide step by step. 1. Keycap Introduction to Pavement Design Flowchart. IRC 37 flexible pavement design follows a systematic engineering process. This process starts with traffic analysis and goes on to final pavement thickness design. And proper design sequence ensures safe, economical, and durable pavement performance. See the engineering note below. Correct design flow improves pavement reliability and durability. And this is the foundation of highway pavement design. Now let us look at the second topic. Step 8. Traffic analysis. Step of pavement design is traffic analysis. Here future traffic loading is evaluated. Now what kind of surveys are there in this? Traffic volume survey, axle load study, growth rate analysis, vehicle classification. And this traffic data further determines the pavement thickness. Now see engineering warning below. Inaccurate traffic data causes unsafe pavement thickness. And this is a common reason for practical design failure. Now let us look at the third topic. 3 Step 2. MSA calculation. Traffic loading is converted into million standard axles (MSA). And for this IRC traffic formula is used. N 365 times A times left frac 1 plus R N 1 R right times F times D. The traffic growth concept graph is also shown along with it. As the years go by, traffic loading also increases. See the engineering note below. Higher MSA requires stronger pavement structure. And this is the main reason for thickness increase. Now let us look at the center flowchart. The complete IRC (37 pavement design process is given here step by step. Start. 1. Traffic survey. 2. Commercial vehicle count. 3. Traffic growth analysis. 4. Vehicle damage factor selection. 5. MSA calculation. 6. Subgrade soil investigation. 7. CBR testing. 8. Selection of design CBR. 9. Drainage evaluation. 10. Selection of pavement composition. 11. IRC 37 design chart selection. 12. Pavement thickness determination. 13. Fatigue check. 14. Rutting check. 15. Material selection. 16. Construction quality planning. Final flexible pavement design. And this is the entire IRC design workflow. Now let us look at the fourth topic. 4-step theme. Subgrade investigation. Subgrade is the pavement foundation. Therefore, soil investigation is very critical. Now what is checked in this? Aggregate quality verification. Bitumen grade selection. Layer stiffness consideration. Durability checking. Moisture resistance. And the CBR laboratory test determines subgrade strength. Now let us look at the fifth topic. 5-step chart. Drainage evaluation. Drainage is very important for pavement durability. Now it is evaluated in side drainage design, cross slope provision, water removal arrangement, shoulder drainage planning. Now look at the right side drainage diagram. Camber is sending surface water towards the side drain, and the side drain is removing the water away from the pavement. Now see engineering warning below. Poor drainage weakens pavement foundation. And this is the major reason for moisture damage. Now let us look at the sixth topic. 6-step 5. Pavement layer selection. Typical pavement composition यहाँ दिखाया गया है. BC layer. Bituminous concrete. DBM layer. Dense bituminous macadam. WMN layer. Wet mix macadam. GSB layer. Granular sub-base. Prepared subgrade. And this is the flexible pavement layered structure. Now let us look at the seventh topic. 7-step 6. Thickness determination. IRC 37 design charts are used to determine pavement thickness. Now on what factors does thickness depend? Traffic loading. CBR value. Design life. Drainage condition. Material quality. अब ग्राफ देखिए. Due to higher traffic increase, pavement thickness is also increasing. And with higher CBR the thickness is decreasing. Now let us look at the eighth topic. 8-step 7. Fatigue verification. Checks pavement safety against repeated wheel loading. Now what is its purpose? Prevention of fatigue cracking. Control of tensile strain. Improvement in pavement life. Now see the engineering concept below. Lower tensile strain. Better fatigue resistance. And this is fatigue design philosophy. Now let us look at the ninth topic. No-step art. Rutting verification. Controls permanent deformation. Now what is its purpose? Prevention of permanent deformation. Control of vertical compressive strain. Better riding quality. Now see engineering warning below. Excessive rutting reduces pavement safety. And deep rutting can also increase accident risk. Now let us look at the 10th topic. STEP No. Construction quality planning. Good design will be successful only then, when the construction quality is proper. Now what planning is done in this? Density testing. Layer thickness checking. Temperature monitoring. 1. Pavement design logic. Pavement design logic is given below. Traffic load. Stress generation. Layer load distribution. Subgrade stress reduction. Safe pavement performance. And this is the multilayer pavement behavior concept. Now let us look at the 12th topic. 1. Practical site observation. Incorrect CBR testing leads to unsafe design. Poor drainage reduces pavement life. Overloaded traffic accelerates failure. Weak compaction causes early distress. And these are the field engineering observations that are seen the most. Now let us look at the 13th topic. 3 Important engineering concepts. Flexible pavement acts as multilayer system. Wheel load stress reduces with depth. Bituminous layer resists tensile stress. Granular layer distributes wheel load. Subgrade acts as foundation layer. And this constitutes the complete behavior of flexible pavements. Now let's look at the 14th topic. 4 Interview question box. Q. Why is flowchart sequence important? Answer. It ensures proper design methodology and reliable pavement performance. Q. Which factor mainly controls thickness? Answer. Traffic loading and subgrade CBR value. Now let's look at the 15th topic. 5 Design verification concept. Both fatigue and rutting verification concepts are shown here. Fatigue. Tensile strain control. Rutting. Compressive strain control. And both the criteria should be within the IRC limits. Let's look at one short revision at the bottom. Traffic analysis. MSA. Soil strength. CBR. Drainage. Protection. Fatigue check. Crack control. Rutting check. Deformation control. IRC 37. Design guide. And this is the complete IRC 37 flexible pavement design flowchart. Why do you find this CI engineering series useful? So do subscribe to the channel. And now on to the next slide. We will understand the complete flexible pavement revision summary and final concept notes. SLID 35. Important formula sheet. So friends, till now we have understood the entire IRC 37 pavement design process in detail. But now the most important revision slide starts. And that is important formula sheet. Because formulas play a very critical role in pavement design. if you don't understand the formulas properly. So the design calculation may be wrong. And these essential IRC SATs formulas are explained in this slide. So let us understand the entire slide step by step. 1. Keycap Introduction to Pavement Design Formulas. IRC SATs traffic, stress, strain, and material-related formulas are used in flexible pavement design. Proper understanding of these formulas improves pavement design accuracy. See the engineering note below. Formulas convert field data into engineering design decisions. And this is the actual calculation philosophy of highway pavement engineering. Now let us look at the second topic. Though design traffic formula. This is the most important pavement design formula of IRC SATs. Traffic loading is calculated in million standard axles IMSA. N 365 times A times left frac 1 plus R N 1 R right times F times D. Now what are the variables in this? N. Design traffic in MSA. A. Initial commercial vehicles per day. R. Growth rate. N. Design life in years. F. Vehicle damage factor. D. Lane distribution factor. अब नीचे engineering concept देखिए. Higher traffic. Higher pavement thickness. And this is the fundamental concept of thickness design. Now let us look at the third topic. 3. California bearing ratio formula is used to determine subgrade strength. CBR frac text test load text standard load times 100. See the engineering note below. CBR represents subgrade supporting strength. And this indicates the pavement foundation capacity. Now let us look at the fourth topic. 4. Vehicle damage factor formula. Vehicle damage factor (VDF) converts axle load repetitions into standard axle repetitions. VDF frac text number of standard axles text number of commercial vehicles. Now what is its purpose? Actual axle load damage evaluation. Equivalent standard axle conversion. Pavement traffic analysis. And this determines the pavement structure loading. Now let us look at the right side pavement layer system. Typical flexible pavement layers are shown here. 1. BC layer. 2. DBM layer. 3. WMM layer. 4. GSB layer. 5. Prepared subgrade. And this layered pavement system distributes the load. Now let us look at the fifth topic. 5. Stress distribution concept. Wheel load is spread downwards in the pavement layers. Vertical stress decreases with depth. Sigma_Z frac P pi Z2. Now let us understand variables. Z. Vertical stress at depth Z. P. Wheel load. Z. Depth below pavement surface. Now see the engineering concept below. Stress decreases with increasing depth. And this is the flexible pavement load distribution mechanism. Now let us look at the sixth topic. 6. Fatigue failure relationship develops from repeated wheel loading. This is tensile strain based criteria. N_FK_1 left frac 1 value_psilon_T right K_2. Now here in F fatigue life T tensile strain at bottom of bituminous layer K1 and K2. Empirical constants. See engineering note below. Lower tensile strain. higher fatigue life. And this is the fatigue resistance concept. Now let us look at the 7th topic. Sath rutting failure relationship is compressive strain-based failure mechanism. N_RK_3 left frac 1 where epsilon_V right K_4. Now let us understand variables. NR rutting life. V vertical compressive strain on subgrade. K3 and K4 empirical constants. Now see engineering warning below. Higher compressive strain, higher rutting risk. And this is the reason for wheel path deformation. Now let us look at the 8th topic. Art pavement layer thickness concept. Now the engineering relationship is shown here. High traffic, thick pavement. Low CBR, thick pavement. Good drainage, better performance. Strong subgrade, lower thickness. And this is the thickness selection philosophy. Now see the right side wheel load and stress distribution diagram. Stress is maximum on the surface, and it is gradually decreasing with depth. This is the layered pavement stress mechanism. Now let us look at the 9th topic. Gnaw density formula is used to evaluate compaction quality. GNUI learning block V3 content row frac MV. Now here, density N, mass V, volume. Now what is its importance? Compaction control, strength improvement, settlement reduction. And this is the basic principle of field density testing. Now let us look at the 10th topic. MOISTURE content formula controls soil compaction behavior. W frac W_W, W_D times 100. Now let us understand variables. W moisture content, WW weight of water, WD dry weight of soil. And proper moisture content is necessary for effective compaction. Now let us look at the 11th topic. One layer compaction concept. Compaction is the most important construction parameter of pavement durability. Text compaction, frac, text, field density, text, maximum dry density, times 100. See the engineering note below. Proper compaction increases pavement durability, and inadequate compaction causes early pavement failure. Now let us look at the 12th topic. 1-2 pavement service life concept. Pavement service life depends on many factors. Traffic loading, drainage condition, material quality, construction quality, maintenance practice. Now see the engineering concept below. Better construction, longer pavement life. And this is the highway pavement performance philosophy. Now let us look at the 13th topic. 1-3 important engineering relationships. High MSA, thick pavement, low CBR, weak subgrade, poor drainage, early failure, low density, weak pavement, proper compaction, better durability. और यही core engineering relationships हैं. Now let us look at the 14th topic. 1-4 practical site observation. Incorrect traffic estimation affects pavement thickness. Weak subgrade increases deformation risk. Poor compaction reduces density achievement. Water infiltration weakens pavement structure. And these are common field observations. Now let us look at the 15th topic. 1-5 Interview Question Box. Q. What is the purpose of AIM-SA formula? Answer. To calculate cumulative traffic loading during pavement design life. Q. Why is CBR important in flexible pavement design? Answer. CBR indicates subgrade strength. Let us see the complete revision concept at the bottom. AIM-SA. Traffic loading. CBR. Soil strength. Fatigue equation. Crack resistance. Rutting equation. Deformation resistance. Density formula. Compaction control. Good drainage. Longer pavement life. IRC 37. Safe and economical pavement design. Why do you find this CI engineering series useful? So do subscribe to the channel. And now on to the next slide. We will understand final quick revision notes and complete flexible pavement summary. So engineers, today we successfully completed part 4 of IRC 37 flexible pavement design. And to be honest, this is the section where the real engineering of the actual pavement design begins. This entire part we understood step by step. IRC 37 pavement design procedure. Numerical pavement design example. Important IRC clauses and provisions. Flexible pavement design flowchart. Important formula sheet. That means we covered the entire engineering concept from design procedure to calculation and IRC logic. Now always remember one thing. Pavement design is not just about deciding the thickness. This is science. This is an engineering judgment. And this is a plan to carry future traffic safely. If the traffic estimate is wrong, so the pavement may be unsafe. If the CBR selection is wrong, so the foundation may be weak. If drainage is ignored, so even the best pavement can fail quickly. So always remember. Right traffic data. Right soil investigation. Right design logic. Right construction practice. Equal to long-lasting pavement. Let's do a quick master recap. Traffic survey. AIM-SA calculation. CBR testing. Thickness selection. Fatigue check. Rutting check. Final pavement design. And this is the complete IRC 37 pavement engineering workflow. Now what is going to come next? We will do complete revision in part 4B, where there will be interview questions. Viva preparation will take place. One shot revision. Memory tricks. And the entire pavement engineering concept will be revised at the mastery level. That is if part 4A is the foundation. So part 4B will be your final preparation. So don't miss the next part. Because only those concepts will convert into confidence. You find this CI engineering series useful. So like the video. The comments which topic you want next. Share it with your civil engineering friends. And do subscribe to Civil Engineering Infrastructure CI channel. Because here we understand highway engineering, pavement design, QA/QC, IRC codes, MOA-TH specifications and real site practical knowledge in easy and technical way. So see you in part 4B. Until then, keep learning, keep building, keep growing. Jai Hind. अगर आपको यह कंटेंट हेल्पफुल लगा है तो लाइक करें, कमेंट करें और शेयर करें और सब्सक्राइब जरूर करें, क्योंकि आगे आने वाला पार्ट 4 भी आपकी प्रिपरेशन कंप्लीट करेगा। स्ट्रॉन्ग डिजाइन, स्ट्रॉन्ग अंडरस्टैंडिंग, स्ट्रॉन्ग इंजीनियर। मिलते हैं नेक्स्ट पार्ट में। जय हिंद।